In this video, we want to compute the bracket polynomial of the Hopf link. So you already see the Hopf link right here. The first thing we want to do is untie this upper crossing. So how does that go? Okay, we go along the top strain, and then we want to turn left. So this will give us the following picture. Going along with the pointer, we go along the top strain, then we turn to the left, and then we go along the rest of the knot. So this is the picture I will get. And in front of that, we're going to put an A. So we're going to get A times going along the top strain, turning to the left. This picture up here. And then plus, and now we're going to get the B. And for the B, we're going to turn to the right. So we're also going to go do that with the pointer. We go along the top strain, we turn to the right, and then we're going to go along the rest of the picture. And let me one more time show you that it doesn't matter which side I go. If I go along the top strain from the other side, yeah, now I have to turn right. So this is going to be this, and then I'm going to go along this way. Yeah, so I should end up with the same picture. So this is the first step. And so in this picture, we have two crossings, so we have to untie both crossings. So the second part, we're going to untie these bottom crossings separately. So we have here the A that we keep, and then, well, we open the bracket, so we have to redo everything. So first here, we go again along the upper strain, and then we're going to turn left to get A. So what do we get here? We're going to go here, turn left, and we get this unknot, and then on the other side, we're going to get this part. So don't forget the A. And then the picture is as following. And now we do the same for the B. We turn right, get here the B. With the pointer, how does that go? We go here along here, we turn to the right, and then we go along the rest of the knots. So this picture. And this is it. So this untied the bottom knot on the left picture, and now we're going to concentrate on the bottom crossing on the right picture. So we get here the B, don't forget the B, open. We go along the top, we turn to the left. This will give us an A. Let us look how this looks like. We go along here, turn to the left, follow along, and we're going to get this picture. Let me redraw this picture here. Go along here all the way. Great. And now we do the same with B. So B here, go to the right. How does that look like? Well, we go along top strain, turn to the right, and go all around, and then we're left with this inner circle here. So overall, we're going to get an outer circle and an inner circle. And so now we're left with only unknots, no more crossings. So what can we do here? First of all, here we have, in this first picture, I'm looking here, I have two unknots. So one of them can go out as a C. This here is just the unknot. By this, I mean the second part here. So this becomes just one. Here, I also have the unknot. So this also just becomes one. And so now this one might be a picture that looks a little bit different than what you've seen before. Yeah, usually your unknots were left and right of each other, but it doesn't matter. This is in or out, but it's still going to behave the same way, whether or not it's inside of each other or next to each other. So we can take one of these, let's say the inner circle, and that can go out as a c, and then the rest becomes 1. So let us summarize what we get overall. Here we get a times c, so a squared c, plus a times b times 1. Next, b times a times 1. So let me just write a plus b, plus, and here we get b times c. So b squared c. So this is the bracket polynomial, and then I can kind of rewrite it as a squared plus b squared c plus 2ab. And then I'm done.